Welcome, my name is Wayne Hesh. I'm the product manager for Visual MODFLOW Flex. We'll get started on the webinar. It's the second session that we've done. We did one yesterday as well in the morning. So we'll record the session in case there's any audio problems and also make it available if you wish to share it out with your colleagues. If you want to send any comments as we work our way through, you can use the chat option in GoToMeeting, which most of you have figured out how to use, so I appreciate that, and thanks for being patient as we work through any technical issues. And my email address is shown on the screen, so if anything comes to mind afterwards or you start using the software, feel free to send me an email address. And as I mentioned, we'll be recording the session and make the link available on our blog site within the next couple days. So the key areas of focus that we've done in this latest release of Visual MODFLOW Flex, which came out in June of this year, the bulk of the areas were on numerical modeling. The key areas would be in the enhanced simulation capability. So we've added support for MODFLOW-NWT, which is ideal when you're working with water table aquifers and you have dry cell problems, which can also occur in dewatering scenarios. We've overhauled the way we handle pumping wells in the conceptual and numerical model. And in a nutshell, it basically means wells now are defined on a per well basis, including the screen information and the point source concentrations instead of on a cell by cell basis. And we'll get into the benefits that provide shortly. The other key area we've improved on would be ease of use in numerical modeling. So there's several new options for assigning properties, bounding additions, inactive cells using digitizing tools such as assigning with line, polygon, single cell, and also options to copy parameters to other layers in the model. We've had options for time markers and travel time settings for mod path scenarios. And we have this new option in the Flex viewer that allows you to better link the data you see in the workflow to the Model Explorer, and I'll show an example of that shortly. And then as part of improvements to the pumping wells, we've also improved the handling of time-related data, so you can now import, view, and edit pumping and observation well data in relative time formats, and I'll provide a few examples of that shortly. So first, a bit more on MODFLOW-NWT. We have support for both the 32 and 64-bit versions. For those of you that keep track of the latest releases from the USGS, we've included version 1.0.9 with vModFlex. You can switch over to MODFLOW-NWT if you have existing vModFlex projects in both after conceptual to numerical model conversion or any numerical models that you may already have. It's pretty straightforward. Just choose the engine at the compose engine step as shown on the screen here. Or alternatively, if you have Visual MODFLOW Classic projects that utilize NWT, you can import those into vModFlex and run them directly. Within the vModFlex GUI, we have support for the keyword solver options, so those simple, moderate, and complex settings that you can define for the NWT package. MODFLOW-NWT also has a specified option for the solver parameters where you can go and adjust each individual parameter. We don't have the full GUI for all that, so if you wish to adjust some of those parameters, you can do that through the text file of the NWT package, and I'll show you how to do that afterwards. The other big improvement we made in this version is to the way you work with pumping wells in both the conceptual and numerical models. So we had a few challenges in the previous versions of vModFlex, namely that there was a disconnect between the data in the conceptual model and the numerical model for pumping wells. The other big limitation is that when you're working with wells that are screened over multiple layers, those are broken up into cell-by-cell pieces. So you would sometimes lose the whole concept of a well that's screened over a couple layers in the model, and it was very difficult to edit the parameters. There was also challenges when editing the point source concentrations and also visualizing the wells. So For those of you that are familiar with VMod Classic, we now follow a similar approach to handling wells in VMod-FLEX, which is kind of a conceptual representation of wells. You define the well location and the screen interval and pumping schedule and pumping rates, and VMod-FLEX takes care of the rest in terms of how that pumping rate is partitioned over different layers and whatnot. This also offers shared data between the conceptual and numerical model, so there's really only one wells object. If you make a change to the pumping rate in the conceptual model for the pumping wells, then it'll be updated in all the numerical models that were derived from that conceptual model. This now allows you to edit the conceptual pumping well object, whereas that wasn't possible in the previous versions. And as I mentioned, that'll update any numerical models. So it provides for more synchronized data. There's less manual updates, and then also at the same time, fewer opportunities for errors. We show and provide a database view for the pumping well data that shows the screen and the pumping rates, and I'll show that in the next screen. And this gives you a nice view of all the wells and the well geometry at a glance. In general, because there's been quite a few improvements to the wells in this new release in terms of visualization and handling the data, we recommend that if you have old VMod-FLEX projects that have pumping wells, that you convert those old wells into this new format so that you can utilize all the features that are available in this latest release. There are instructions on how to do that in the user's manual, and there's also, I believe, a small article written up that provide step-by-step instructions on how to do that. If you have any questions or you get stuck, then feel free to contact myself or our tech support group. So this is the new interface that we have for pumping wells. This is the window you'll see for both the numerical model and the conceptual model. If you're creating a new pumping wells object, you simply first have to import an Excel file that has the pumping location, the screen, and the pumping schedule, and then you map to that using the blue arrow that's shown here. The layout is very similar to VMod Classic. On the left side you have the well heads, which contains the well name, XY location, the elevation of the well, and the depth or the bottom elevation. Another new feature we've added in this release allows you to turn wells on and off, so you can make them active and inactive, and that will be included with the well package translation. In the top right, you have the screen information where it has screen ID and the top and bottom elevation of the screen. And in the bottom right, you have the pumping schedule, which provides the start and end times and the pumping rates for each period. Note that we've also included now the species concentrations as an additional parameter for each well, which again makes it easier if you're handling transport models and need to define point source concentrations. These can now be defined on a well basis as opposed to a cell-by-cell basis. And again, since the conceptual and numerical wells object is shared, it makes it easier for you to evaluate several numerical models from the same conceptual wells object. So as I mentioned, the key improvements are that these parameters are now defined on a per well basis instead of on a cell-by-cell basis, as it was the case with the previous versions of VMod-FLEX. This gives you better handling of parameters, now allows you to define the whole pumping rate over an entire screened interval, and also allows you to define point source if you're doing a transport simulation. Another nice feature that's come out of this change is that if you are working with just a couple wells in a model and you don't have an Excel file, you can add wells with a mouse click at a specific location in the layer view in the numerical model. So if you've got perhaps a shape file that has the well locations, or you know where you want to place some potential test wells, you can just click with those on the desired location in the plan view and then define the well parameters from there. This has also allowed a lot more visualization options, so you can show the well name and the screen interval for the conceptual well in a 2D and 3D view. There's more rendering options, which I'll show you in the next screen, so you can color the well by the pumping or injection rate, or also by the concentration. You can show wells, screens, and the well location in a 2D plan view and also in a cross-section along a row or column. As I mentioned, you can set individual wells to be active or inactive. The well name will now appear as a line in the well package, which is a nice way to do QA/QC and compare where your well location is to a corresponding layer row column. And then lastly, if you want to do further analysis, you can export your well data to a CSV file. Here are a few examples of the new visualization options. On the left, you have a cross-section view showing wells that are screened in different layers. The well screen is colored in yellow. The dark brown line shows the entire well path from the top to bottom. And you can see at the top, you can label the well name in order to correlate the different locations. On the right, you have a figure showing the plan view of the well location, and in this case, the wells are colored by the pumping rate. So this is a nice way to get different trends. Maybe you're dealing with hundreds or thousands of wells, and you need to see what areas of the model you have higher pumping over lower pumping, maybe on a layer-by-layer basis. In this case, the color rendering is use the classification such that those colored in blue have the higher pumping, and those colored in red have the lower pumping or no pumping at all. Other areas where we've improved now would be in the numerical modeling capability, specifically assigning parameters or editing parameters or improving the functionality for building numerical model objects. As I mentioned, for pumping wells, you can add individual wells through the click of a mouse or edit single wells. If you're working with bounding conditions, you can assign those to be copied over multiple layers. This is a common request when you're doing constant heads, for example. If you've digitized a line or a polygon along the edge of the model, you can have that copied down to additional layers in the model. So this is possible for constant heads, specified flux, and a few others. In addition, we've enhanced the functionality for property zones. So now you can assign property zone cells, either a new zone or cells to an existing zone using individual cells. So clicking on a single cell, which would be ideal for just painting a couple cells. You can assign a property zone using a polyline. Just a remark there, when you use these options, there's no conceptual model equivalent that's created for the property zone. So if you were to convert a conceptual model to another numerical model with these changes, those changes that are done specifically to that numerical grid will not be propagated down to that other numerical model. In addition, when you're working with inactive cells, we've added the assign single and assign polyline to that window as well. And another nice feature, if you want to have inactive cells span through multiple layers, perhaps you've defined some edges of the model domain that you're not interested in using polyline or polygon, you'll see here there's an option to assign over multiple layers. You can select individual layers or have it apply to all layers. We've also had a new option for working with and displaying time-related data. So previously, you would just see most of the raw data in absolute times. This means, for example, like a calendar date, October 7th, 2015, for example. But we found that there's a lot more needs to have well data, whether it be pumping schedules or head observation data shown in relative times relative to an arbitrary starting date. This gave us a lot more capabilities in terms of making comparisons to VMod Classic models and just overall data consistency. So this means now you can show your pumping schedule data in the spreadsheet view in relative time, such as 30, 60, 90 days, what have you. The same is true for the observation data for your head observations or concentration observations. You now have an option to import pumping schedules and head observation data in relative time formats. You just choose that option during the import. And then, as I mentioned, you can display that in relative times afterwards. Some other improvements we've made would be the handling of boundary conditions that end at various end times. So it's possible in VMod Classic and also in MODFLOW to have boundary conditions that don't all end at the same stress period. And ideally, you want to have your data set up to handle that appropriately, either by putting in the appropriate stop time or zero cells or zero parameters. But in practice, as your models grow in complexity, we find that many users forget to set up all the stress periods correctly. So this means, for example, if you have a constant head that goes for 2 stress periods, maybe from 0 days to 2 months, but then perhaps you have recharge or pumping wells that go for 1 year. The way this is handled in VMod Classic is that the translation step will just extend those boundary conditions that don't end at the maximum time with 0 cells. So this means then the simulation time will be calculated to be the maximum possible time from all the boundary conditions in the model. In the case of pumping wells, then a 0 pumping rate will be injected for those wells where there's no data available. In the same theme of pumping wells, we've added an option where you can automatically insert 0 pumping rate for wells that don't start at the same date. So if you imagine you have a very large model or even a moderate sized model where you have tens or hundreds of wells, and in the nature of pumping wells, they don't all start on the same date, but you want to be able to simulate that. If you define your boundary conditions and you import that raw well object and you need to add those wells to a conceptual well in VModFlex, you'll get a notice that says that certain wells don't start at the same date. And what we'll do is we'll automatically give you an option to add a 0 pumping rate for those wells so they can be included and synchronized to start all at the same date without you having to go through and manually define all the tedious work. So you're certainly free to fix it within Excel yourself, but if you have a very complex file that you've got from a client and you don't want to be bothered with that, then you can add that in there and we'll take care of that conversion for you automatically. So what you would see then for any wells that start after a particular well, you would just see 0 pumping rates up until the time when that well becomes online. We've also added some additional options for path lines when you're running ModPath for both forward and backward path lines. You can now define the tracking time to be either steady state or whatever user specified travel time you want to use. And there's some options for the Pathline markers. You can have irregular intervals, let's say every 1 year, or every 30 or 60 days, for example. Or you can have some custom intervals defined in the grid shown here. So this can allow you to do and create a figure with the backward wellhead capture zone as shown in the figure in the bottom. The next area we've improved on is in the Flex Viewer in the toolbox. So this would be the window that you see when you're working within the numerical model at the properties step or the boundary condition step, and also when you're working at the map step when you're looking at the results. What we've offered is a better link between the data objects that you see in the view and what are available in the Model Explorer. So previously, if you wanted to adjust certain things such as the settings or the, let's say the contour lines for the heads, for example, you'd have to access that through the settings, which would be available from the heads object on the Model Explorer, which could be quite complex if you have multiple numerical models or conceptual models, and could be rather difficult to find that desired object. So what we have now is this called an objects in view. I have shown a blow-up figure of that in the figure shown here. It provides you a list of all the data objects that are shown in the view at the time. So in this case, if you're at the property step and you're showing the connectivity, then you'll have a list of connectivity, and maybe you've added other objects such as a shapefile, for example. A couple different things. You can click on the settings button, will take you right to the settings window for that object. So again, if you want to change the contour interval or change the display properties, it'll provide a quick and easy shortcut to that window. The isolate option will show you only that selected data object. Again, it's useful if you have maybe tens or quite a lot of objects shown on the screen and you want to see just that particular object. The red X option allows you to remove that object from the view. There's a highlight in the model tree option, which again allows you to link what's shown in the screen to the Model Explorer. And then the last option, which is here, this drop-down menu, will provide you a shortcut to any of the options that are available if you were to right-click on that object on the tree. So let's say you want to edit the attributes or delete that bounding condition because you don't need it anymore, for example, or you want to export it out. In the past, you'd have to go to and find that object on the Model Explorer or the tree and then right-click on it. Now you have that capability right from within this Objects in View window. So this is a new feature that's certainly open for ways we can improve this. So please send us your comments as you start working with it if you have any other things you'd like to see to better synchronize what you see in the main windows to the data objects in the Model Explorer. We've added an option for operations for surfaces. For those of you who weren't aware, you can load operations for a variety of data objects such as points, polylines, images. This is through the settings window. If you go to the operations option as shown here, it allows you to do different arithmetic and geometric calculations to an object. So let's say you want to shift some polylines up by a certain elevation or drape it over a surface. That is something that's possible. So we've added new operations for a surface that lets you move a surface up or down by a specified value. This could be useful in a variety of scenarios. Let's say you have a surface that represents a specific formation. You just want to make a unit that's 10 meters or 10 feet thick. You could just create a copy of this surface and save it with a Z value that is -10 or 10 less than what's there right now. The same could be true if you want to have a surface that represents the river bottom from which could be 5 feet or meters below the ground surface. You just load these operations, put in the desired value. It's shown down here. And then there's an option where that new surface will be saved as a new data object. At the translate step, we now show a tab preview of all the input files or packages that are used for whatever engines you're utilizing in your simulation. For those of you that have worked with MODFLOW-USG, you'll be familiar with this type of layout. So an example shown on the screen here is it'll show you a preview of the well package. We've done this for a couple of reasons. Many users wanted us to be transparent in terms of how the vModFlex GUI works and how it makes input files. I've got this question quite often if we make standard input files for MODFLOW and MT3D, and the answer is yes. You can take those input packages and files and run them outside the vModFlex interface if you want to do batch runs or whatnot. So I want to kind of educate those people that aren't aware of the different input packages and what they look like so that you know that we're making these files. It allows you to preview those input files. You can get a better understanding of what the file formats are and the file structure. And then most importantly, you can do QA/QC to see if there's any problems. Certainly bugs come up from time to time, so if you see something that doesn't make sense in the package, you may want to go back to making sure and see that you've put in the right parameters in the GUI and that things are getting translated correctly. This is also a place where you can directly make edits in this window here. You just, like I said, it's a text-based window. You just change whatever values you wish, and then when you're done, you need to right-click and then save in that window. And this would be one place where you could change those NWT parameters that I mentioned on one of the opening slides. For those of you that are working with MODFLOW-USG, we had a few requests to add support for calculating and displaying the water table. So this is now available for the Voronoi grids. An example is shown on the screen there. You can show the water table. It does appear as a surface object. You can change the color classifications and the contour interval. And then if you wish to do further post-processing using Surfer or ArcGIS, you can export out the water table values at each grid node. This will be exported out to a CSV file. For regular MODFLOW runs, so for MODFLOW 2000, 2005, NWT, and LGR, we now calculate the fluxes and allow you to visualize that in a 3D viewer. So this is extracted from the MODFLOW BGT file. You can show the flux in and out of each individual cell. I believe it also shows you the flux to adjacent cells coming from the left or the right or from top or bottom, for example. And then we also calculate the base flow, so the net flow in minus the net flow out, and show that in a 3D viewer. So it's a nice way to get at a glance where you have fluxes going into and out of your model through different bounding conditions, etc. So the example on the screen there shows you from river bounding conditions the base flow. So we've made many other small improvements. I looked at the README file the other day, and the whole list of changes. We've added more than 80 new features in this release and several important bug fixes. These you can access the release notes from the help menu within the software. If you click on the website that's shown there, it'll provide you with the list of all the changes. This is shown on the screen there. Just take you right to our website. It shows you which build we had for the release number and all the changes that we made. So I encourage you to take a look at all the improvements that we made, and certainly send us your feedback in terms of other things you'd like to see in future releases of the software. All right, that brings us to the end of the webinar. Thank you for your time. If you have any questions at this time, I'll do my best to answer those for you.